There are 25 bikes and trikes at the park. The bikes and trikes have 60, God bless you, have 60 wheels in all. In the graph, the red dots show sums of 25, and the blue dots show 60 wheel combinations. So the red dots represent the sums of the bikes or trikes. The blue dots show the possible opportunity to be a bike or a trike with 60 wheels. How many bikes and trikes are in the park? So at the moment, we don't see a point of intersection. So what we would need to do is extend both of these lines further to see where they intersect. So I could write equations to represent that. So my first equation would be that x plus y has to equal 25. I know this because I'm told there are 25 bikes and trikes at the park. They represented x with bikes and y with trikes. I also know that the bikes and trikes have 60 wheels in all. So how many wheels does a bike have? So it would be 2x. How many wheels does a tricycle have? 3 for try, like a triangle. So we have 2x plus 3y equals 60. So how do I find where the actual combination of bikes and trikes at the parks are? What could I do? Since I can't see it on my graph, how could I do this algebraically? There are two possible answers you could give me. What do you think? Yeah, Isabel, you're good. Yeah. Okay, we could put them into y equals mx plus b, so I could solve that first equation for y, right? So if I solve the first equation for y and put it into y equals mx plus b form, I get y equals negative x plus 25. What I could do is take this and replace y here. So what's that method called when I take one piece and replace it in another? Okay? Substitution. Excellent. So we're going to substitute. So we get 2x plus 3 times negative x plus 25 equals 60. And then what do I have to do from here? What's it called when I take that 3 and multiply it in? The distributive property. So we're going to distribute. And then I'm going to combine like terms. So I get negative x equals negative 15. Dividing both sides by 1, rather negative 1, I get x equals 15. Which means that there are 15 bikes. If there are 15 bikes, then I have, go ahead, Ryan. Careful, it's negative 15. Yeah, so 10. So I have 10 trikes and 15 bikes in the park. If you have one point of intersection, this is what type of lines? There's one point of intersection. What type of system of lines is this? Independent, dependent, inconsistent. What do you think, Nick? Not inconsistent. Independent. Good. Okay, and then for the second part, it says solve each system by graphing. Check your answers. So we are going to graph each of these equations. So number 1, my y-intercept is -2. So we're going to plot a point at -2. My slope is +1, so it goes up 1, right 1, up 1, right 1. So there's my first line. My second line has a y-intercept of 7. And a slope of -2. So it goes down 2, right 1, down 2, right 1. So where do these two lines intersect? They intersect right here at the point 3, 1. Therefore, the solution to this system is 3, 1. So it says solve each by graphing. So the solution is 3, 1. So if I ask you to solve by graphing, you need to tell me what the solution is. So in this case, the solution is 3, 1. Number 2, y equals -x plus 3, and y equals 3 halves x minus 2. So we're going to plot our y-intercept on the first equation. So it's at +3. My slope is -x, so it goes down. Once I have a couple points, I can connect my line. And then we plot our second graph. So its y-intercept is -2. My slope is +3 over 2. And once again, my two graphs intersect. That point of intersection represents the solution. So the solution is that point of intersection right there. Or in this case, solution is what? It would be 2, 1. You always list the x coordinate first and then the y. in number 3, we have 2x plus 4y equals 12. What form is this equation in? Standard. Excellent. So if you're given a graph in standard form, you have two choices. You have to either put this in y equals mx plus b, or you have to start with your x and y intercepts. If I transform that equation to y equals mx plus b, then the top equation becomes y equals, back over the 2x, so you get negative 2, but you divide that by 4. So negative 2 divided by 4 is negative 1/2 x. And then it would be 12 divided by 4, which is 3. So you get y equals negative 1/2 x 3. And then the second equation you'd subtract over x, so you get y equals negative x plus 2. So plotting those points, you start at 3, go down 1 over 2, up 1, left 2, and graphing our line, we have this. For your second line, you would also plot that positive 2, do your negative slope, connect your points, and once again, my two graphs intersect, this time in quadrant 2. So their solution would be negative 2, positive 4. We can also have graphs that are horizontal or vertical. So x equals negative 3 is going to be straight up and down. And y equals 5 is straight across. So a horizontal and a vertical line still intersect. They intersect right here. And in this case, that point would be negative 3, positive 5. So my solution is negative 3, positive 5. In number 5, we solve for y in the top equation. And you get y equals negative 2x divided by negative 2, so you get positive x. 4 divided by negative 2 is negative 2. So for the first equation, it goes through negative 2 and has a slope of positive 1. The second equation, that y to the other side, we get y equals x plus 6. What do you notice about these two equations? What do we notice about those two equations? What do you think, Nick? Yeah, they're the same slope. So if two lines have the same slope, do they ever intersect? No. If two lines never intersect, do they have a solution? No. So these are parallel lines. Parallel lines have no solution. Parallel lines have no solution. Okay, looking at example number 6, plotting some points. Solving for y, you get negative 3x plus 5, so my y-intercept is 5. My slope is negative 3, so you go down 3 over 1, down 3 over 1. Once you have enough points to get that graph, you connect them. Plotting our second line. In this case, you'd move over that x. It'd be negative, but then you have to divide by a negative. So you get y equals x minus 7. So my slope is positive 1, but the y-intercept is negative 7. And once again, my two graphs intersect. The point of intersection right here is known as my solution. So in this case, my solution is at 3, 4. Sorry, negative 4. Thumbs up, you're feeling good. You can graph these. You're on it. We're good? Okay. So here's the outline for the rest of the week. Tomorrow we're going to do a review on Kahoot. If we finish the Kahoot review, then you can start your quiz. That quiz will be due on Monday. So we are doing the 3-1 skills worksheet in your packet. And then you have to upload before class time tomorrow that handout and the other handout. Yeah, it should be the last page of your packet. You are probably, from what I recall, that 3-1 skills practice, you're probably able to graph it all on there. If you need to do work on a separate page, that's totally fine too. But it's pretty much set up that you can do it on that handout. I believe it was homework day 3. You have to upload with that to Fusion tomorrow.